This video is going to cover an overview of order of operations. This topic is absolutely critical for moving forward in algebra. So this video might be a little bit longer than usual in order to make sure that we cover all of the bases and that you are really clear on what order we carry out our operations in. So the question involved here is, if we have more than one operation, which one should go first? So for example, we have 2 plus 4 times 3. So we have adding and we have multiplying. And you might be tempted to say, well, going from left to right, I see adding first. And so maybe I should add first. So let's take a look at how that would work out. So we have 2 plus 4 times 3. And if you added first, you would get 2 plus 4, which is 6. And then 6 times 3 is 18. And so you're thinking, all right, well, this is good. I did adding, I did multiplying, I have my answer. Or should we multiply first? So coming over here, let's go take a look and see what happens if we multiply first. If we multiply first, we have 4 times 3, which is 12, and then 2 plus 12, which is 14. Now, these answers cannot both be correct. And we know that there's got to be one correct answer because we know that math works. We know that we are able to put space shuttles in orbit and we are able to build bridges. And we're not doing that because the engineers that are doing the math are getting more than one right answer and you just have to pick which right answer you want. So the answer to this problem is either 18 or it's 14, but it cannot be both. So order of operations really addresses which one goes first. And unfortunately, when order of operations is taught, a lot of the time it's presented as simply a set of rules that you, the student, are supposed to memorize. And the fault with that is that if you're just memorizing rules, eventually you will forget the rules. Or if somebody changes the problem a little bit and the rules don't look the same way they usually look, then you'll end up getting it wrong. So let's go and explore this in more detail. Here's the key. Remember what multiplication is. So this requires that you go back to your elementary school and when you first started learning how to multiply. So 4 times 3 is really 4 added in 3 times. It's 4 plus 4 plus 4. That's what multiplication is defined as. It's how many times you're adding in a particular number. It's repeated addition of the same number. Now, what we're going to do is take that definition of multiplication and we're going to apply it to that original problem. So we had 2 plus 4 times 3. I'm going to take that 4 times 3 and replace it with 4 plus 4 plus 4. Which I know I can do because that's what 4 times 3 means. Now, the key here is that now I've taken my problem that had 2 different operations and I've written it to have just one operation, that is addition. And now the order that we do it in doesn't matter. Addition is commutative, so you can add those numbers in any way that you want. So you can do 2 plus 4 is 6, and 4 plus 4 is 8, and then 6 plus 8 is 14. Or you could do 2 plus 4 is 6, plus 4 is 10, plus 4 is 14. However you want to do it. So we could have, we'll just do it the last way that I did there. So 6 plus 4 is 10. Okay, and what that means is that 14 was the correct answer to the problem. So when I did it one way, I got 18 as an answer. When I did it the other way, I got 14. And now we're very confident that 14 is the only correct answer to this problem. So in conclusion, if we have both adding and multiplying, the multiplying should be done first. Now, I'm aware that I did not prove this. I just reasoned this out with one example. But if you wanted to, you could take any number of digits and throw them into a similar problem and you could work them out the same way and it would always come out the same way. That in order to get the correct answer, you would need to do the multiplying first. So in our order of operations, we know that multiplying, represented by the M, would come before you do any addition. Now we can do the same kind of reasoning with exponents, and I think it's really, really important that we do the reasoning out. Now, before we move on, I just want to call your attention to that little asterisk there. That is often used as a substitution for a time symbol when there's no convenient time symbol to use. And so I want you to be aware of that. In fact, some calculators will also do that. I think they're getting better at having good looking symbols for multiplication, but if you have an older model calculator, you'll see a calculator do the little asterisk as well. So in this case, do we multiply first? So we have 3 times 4 squared. So the first thing I'm seeing there is the multiplication. So you might think, well, I just did an exercise where multiplying came first. I guess I'll multiply first. So 3 times 4 is 12. And then 12 squared means 12 times 12, or 144. Or maybe we're supposed to do the exponent first. 4 squared is 16, and then 3 times 16 is 48. Now, once again, these cannot both be the correct answer. And you might be thinking back to a previous video on exponents where I really emphasized that the exponent only goes with whatever is to the immediate left. So that exponent of 2 only goes with the 4. It does not go with the 3. And so you might be starting to feel a little bit uncomfortable with the order that I did that in, and that's a good thing. That's where we want to be with our order of operations. But let's go back to our definition of an exponent. 4 squared really means 4 times 4. So as I did with the previous problem, I'm going to rewrite it. And instead of 3 times 4 squared, I'm going to take that 4 squared and replace it with 4 times 4. And as I did in the previous problem where I turned everything into addition, now we've successfully turned everything into multiplication, which is commutative, which means I can multiply this in any order that I want. So I could do 3 times 4 is 12, and 12 times 4 is 48. Or I could do what I did before with 4 times 4 is 16 times 3 is 48. Either way, 48 was the correct answer, not the 144. So there's really no debate about that. That leads us to our second conclusion, which is if we have both multiplying and exponents, the exponent should be done first. So if I represent exponents with an E, I would do the exponents first, and then I would do the multiplication, and then if I had some adding, that adding would get done last. Now, what I'm trying to do here is instead of just giving you a rule for the order of operations, I want you to see that the rule makes sense and that if you needed to, you could go back and break down the individual operations to get something that would show you which order those operations should be done in. It's not just people making up a rule. Now, what about division and subtraction? We're going to take a look at division and we'll leave subtraction for a future lesson. And there's a really specific reason why we're going to leave subtraction for a future lesson. But I hope that in reasoning through the division that I will establish myself as a trustworthy person and you will be able to take my word for it that the same thing also happens with the subtraction. Now, this is going to require you to, once again, go back to elementary school when you first started learning how to divide. Division means multiplying by the reciprocal. Now I'll do a quick little sidebar here. The reciprocal is when you flip a fraction over. So the reciprocal of 2/3 is 3/2. The reciprocal of 4/1 is 1/4. Okay, so that's what, hang on, definitely not an equal sign there. Is 1/4. 4/1 does not equal 1/4, but we can put the little saying we're taking a reciprocal. Okay, now 6 divided by 2. So now that we know that division is the same thing as multiplying by the reciprocal, 6 divided by 2, we could replace that as, or rewrite it as a multiplication problem. So 6, we'll take that division and we'll replace it with a multiplication symbol, and then we'll take the 2 and replace it with the reciprocal. The reciprocal of 2 is 1/2. So 6 times 1/2, or what might be more comfortable is half of 6. if I read it the other way, half of 6 is the same thing as saying 6 divided by 2. Both of those have an answer of 3. 4 divided by 4 could be written as 4 times, and then the reciprocal of 4 is 1/4. So we could read that as 4 divided by 4 is 1, or 1/4 of 4 is 1. So pretty much any division could be written as a multiplication problem. You would just take the reciprocal of whatever it was that you were dividing by. In elementary school and middle school, sometimes teachers will use a little acronym, which is, I think, keep, change, flip, which makes me very uncomfortable because, again, a lot of times students do not understand what that is a little mnemonic device for, okay? And what it is this reminder of what division is. So if we saw 6 divided by 2 times 4, okay? So this is a problem that has division and multiplication in it. And you might be thinking, well, maybe I should divide first, or maybe I should multiply first. Here's how we're going to figure it out. We're going to take that division and rewrite it as multiplication. So 6 divided by 2 is the same as 6 times 1/2. And what I have done there is I have now taken my problem that had multiple operations and rewritten it so that it has all of the same operation. So you are welcome to do this in any order you want. You can do 6 times 1/2 is 3, and 3 times 4 is 12. Or 1/2 times 4 is 2, and 6 times 2 is 12. Or you could do 6 times 4 is 24, and half of 24 is 12. No matter which way you do it, you should get a 12. Now, what that means in terms of our order of operations is that you have to take care of that division by either changing it to multiplication or carrying it out before you do that multiplication. If you do the multiplication first, you'll get 2 times 4 is 8, and 6 divided by 8 is definitely not 12. And we know that the answer is 12. So what this tells us about multiplication and division is that if we see multiplying and dividing, we go from left to right. So we would do 6 divided by 2, which is 3, and 3 times 4 is 12. That will give us what we know is the correct answer. If you do the multiplication first, you will end up somewhere else. Now, the same thing holds true for adding and subtracting, but it requires that we look at negative numbers first. So coming into Algebra 1, you should already be familiar with reciprocals from your study of fractions. So we can go through this and kind of explain it with reciprocals. But usually when you're starting out in Algebra 1, you haven't had a lot of experience with negative numbers, but we would pretty much do the same thing. So multiplying and dividing, they actually have the same order in your order of operations. You just carry them out from left to right, and the same will be true for your adding and subtracting. So this seems kind of long. If we were to look at this problem, we don't want to think that hard about it. So you might take this problem 2 times 3 squared divided by 3 and say, okay, well, 3 squaring is 3 times 3, and dividing by 3 is the same as multiplying by the reciprocal, and that would take all of those operations and turn them all into a bunch of multiplications, and you could get the correct answer. Or you could simply know your order of operations. So we don't want to expand everything out. It would take a long time. We typically just memorize the order that we do operations. So we would do exponents, multiplication and division, and then adding and subtracting. Your multiplication and division do have the same order of operations, like the same rank, but we would go from left to right, and we would do the same thing for our adding and subtracting. We go from left to right. If it makes you really uncomfortable, you could just rewrite your division as a multiplication, and then you can do it in whatever order you'd like. And the same with your adding and subtracting, beginning with the exponents. So for this problem, we would start with the exponent, which is 3 squared or 9, and then we would go from left to right. 2 times 9 is 18. And 18 divided by 3 is 6. Now, one last piece of our order of operations. That's our grouping symbols. Anything grouped together must be treated as a single entity all to itself. It's like thinking of your family as a single group. If you go into a restaurant, you're treated as a group. So you come in together, you sit at a table together. The people at the restaurant don't go splitting your family up. You are a group. Thus, grouping symbols have to be dealt with first or on their own. Now, grouping symbols include all kinds of things. They include parentheses. They include things like brackets, which we don't see a whole lot except when we're first starting with grouping symbols, but they do come up. Other things, square roots will count as a grouping symbol, meaning anything under that square root is actually grouped together. And in fact, some older model of calculators will open up a square root and then immediately open up a parenthesis under that square root to indicate that it is grouped together. A really common one are fraction bars. Everything in the numerator is grouped together. So if you have multiple operations in the numerator, they are all together like one family. And the denominator is grouped together. And so you need to deal with the numerator and the denominator separately before you begin to try to merge the numerator and denominator together. Now, there's actually more grouping symbols than that. An exponent can count as a grouping symbol. If you saw 3 to the 2 plus 1, then that 2 plus 1 is technically grouped together inside the exponent, and you would do that first. Now, that might seem a little bit overwhelming, but as you go through your math journey, as you introduce new symbols, then that order of operations instruction gets incorporated in it, and it should end up being pretty intuitive. Now, because there are so many potential grouping symbols, when putting grouping symbols into our acronym, we usually just use P for parentheses. It's just really important to know that parentheses are not your only grouping symbol. So I usually write PEMDAS this way, parentheses, exponents, and then I'll put my multiplication division together with a little slash, and the same with my adding and subtracting, putting it together with a slash, reminding myself that these are actually in the same position in our order of operations. And you might have heard this acronym expressed as "Please excuse my dear Aunt Sally," as a way to help students remember it. What unfortunately happens is that a lot of times in math classes, you jump immediately to "Please excuse my dear Aunt Sally," and you are told do parentheses, then do exponents, then do multiplication division, and no one ever goes through and shows you why that these operations go in that order. And I hope that in the last 18 minutes or so, I've been able to show you why these operations go in the order that they do. And if you ever have a question or a doubt, you can go back and do what I did. Find the definition and expand it out and do a comparison calculation to figure out what order your operation should be in. So let's take a look at a quick example. I know this lesson is a little long. In this example, I have grouping symbols here with the parenthesis. I also have a grouping symbol there with the fraction bar. I have multiplication, subtraction, and addition going on. Remember that our grouping symbols get first priority. So what that means is that I have to do whatever's in the numerator separate from whatever's in the denominator. Now, where you can have a little bit of liberty is if you know that you have separate groups, instead of doing everything in one step for the entire problem, which will give you a million steps, you can actually begin to work out your order of operations in each group at the same time. So here's what I mean by that. I know that 2 times 3 is going to get done in that numerator. I can go ahead and also begin work on my denominator doing the grouping symbol that's in the denominator. 2 plus 2 is 4. And so I'm not waiting to finish to do like everything in its own step. I actually did two things in one step there. Now I have to finish the grouping on the denominator. So 7 minus 4 is 3. And only once I have dealt with the numerator and the denominator, or in this case, my separate groups, can I finally merge the groups and figure out what's happening between them. 6 divided by 3 is 2. Always make sure that you are working top to bottom. And while it is possible to do more than one step per line, just be careful that you're not doing too many steps per line, especially if your teacher has given you specific directions about how he or she wants you to set up your problems. Now, one final word. There are some calculators on the market that observe what's called implied order of operations. These are intended to help users avoid errors by assuming an order of operation when expressions are entered in a particular way, even if they are entered in incorrectly. So basically, they're calculators that are trying to read what you meant to do as opposed to what you actually put in. First time I saw that, I was utterly floored, and I thought, why doesn't my calculator do correct order of operations? Now, the other thing you might encounter is some variations of this online where people consider the context and importance of the operations involved. So there can be big fights online about the order of operations. And when you dive deep into that and maybe start exploring what some of the people are saying, now, to be clear, some people just flat out don't know their order of operations, but they'll talk like they do. But others will come in and they'll have some really solid reasoning for why they have done things differently. Now, none of that changes what we've seen in this lesson. Everything that I've showed you in this lesson still holds. I just want to throw those out there so that if you do encounter them somewhere, that you're not totally floored by them and you can engage in a discussion or correcting someone or learning something new in an intelligent way. As always, please like and subscribe if you found this video helpful, and check out the practice set linked here and in the description.